Hi, Algebra 2. We are starting to graph today, so we're moving away from all of your more algebraic things that you guys were doing the last couple days with simplifying and using your imaginary numbers. And now we're going to move into how do we graph some quadratics, because once we know how to work with imaginary numbers, we're going to be able to graph all types of quadratics with the help of imaginary numbers. So we'll be using that link in a couple days. But right now we're just going to go back to graphing and do a little review of graphing as well. If you don't have any graph paper at home, you can do a simple XY axis that looks like this on your paper, okay? So you do not need to make it fancy, but we do want to make dash marks. So if you don't have graph paper at home, you want to make some dash marks so that you can count appropriately, okay? So go ahead and make your own XY axis and a couple dash marks if you don't have graph paper. Otherwise, you can use the graph paper like I have on the right-hand side. And remember, I have copies in class if you ever need them to take home with you. If you haven't already labeled, double check that you guys have 3.3. We're talking about the vertex form of a quadratic. And we always like to start with what the parent function is. And a quadratic function is a function where the x is being squared. So we're talking about y equals x squared. And think about this for a moment. I'm going to add a little xy table right underneath my graph. If I take 0 as my x value and I square it, because y equals x squared. So if 0 is my x and I square it, well, 0 squared means my y is going to be 0. If I do the same thing with 1, 1 squared is 1. Now let me think about -1. If x is -1, what happens when I square a negative number? So -1 multiplied by -1. I'm going to wind up with a positive y value, positive 1. When I start to put this on my graph, I'm going to use black to make my parent function. I have the point 0, 0. I have 1, 1. And I have -1, 1. So I'm going to continue. What if I had 2? Well, 2 squared would be 4. So 1, 2, 3, 4. And -2 squared would also be 4. So if I go to -2, 1, 2, 3, 4. Okay? This almost looks like a V shape, but it's not quite a V. It is actually curved because those square values are changing slightly every single time that we wind up plotting a new point. So if you think about it, 1/2 squared would be 1/4. So we've got a teeny little point right here at 1/2 and 1/4. Okay? So it starts to make a U shape known as a parabola. So we're going to say the shape is called a parabola. Okay, P-A-R-A-B-O-L-A, parabola. If you guys notice, the parent function, the 0, of course, the vertex is on the 0, so right here in the middle. And then your next point is 1 over, 1 up. But then your second point is 2 over and 4 up, because it is being squared. So 1 squared makes 1, so over 1, up to the right 1, up 1. But then 2 squared makes 4, so I'm going 2 to the right and 4 up. So if I did 3, 3 squared would make 9. So I would go 3 to the right and 9 up. All right, so then there's a little basic information about our parent function. Secondly, I'm going to use blue to talk about some of these key vocab words on the left here. Your vertex is the point directly in the middle of your parabola. So our vertex for our parent function is 0, 0. It is the point right in the middle of the parabola. So where is the middle of it? Kind of like you're slicing it in half. And I'm going to go ahead and do that on my picture. I'm going to take the middle and draw a little dotted line down it. If you guys take each half and you fold it over that middle line, you wind up having a symmetric shape because both sides would match up to each other. We call this line that folds your parabola in half the axis of symmetry. Your axis of symmetry is a vertical line. So think back to Algebra 1 for a moment and from our line review at the beginning of the year with linear functions. A vertical line is in the form of x equals. And since it goes right through the vertex, it's always going to be x equals whatever the x value was from your vertex. So I'm going to take x equals 0 because my vertex was 0, 0. The nice thing about parabolas, which is a quadratic function, remember the shape is called a parabola, but the function is called quadratic. The nice thing about them is that they work very similarly as the absolute value function. So when we talk about the vertex form of a quadratic function, what we're saying is now we have whatever value is in front of the x, multiplying by the x, that is also affecting the stretch, just like it did for absolute value. We have minus h, which moves it to the right or to the left, depending on whether h is positive or negative. Because our parent function is squared, so let's take a look. Whoop. Because our parent function is squared, that's what makes this parabola shape. My vertex form is also going to be squared. And then I have my plus k on the outside. Now think about this for a moment. My vertex. Because my vertex is at the point where I'm going to move that middle point to the right or to the left, if I take the h and the k, that's going to give me where my vertex is, because that will tell me if I move to the right or to the left. And we'll do a few examples that will show you that. And then my axis of symmetry, I'm going to say A of S, just so I can shorten it a bit. My axis of symmetry is going to be x equals whatever that h value actually is. Okay? So a couple little pieces of information just about this new function. So far this year we've done linear functions and we've done absolute value functions. Now we're adding a third one, quadratic functions, and we'll bring them together at the end of the notes today. So let's try to put this into action. With this first one, this equation is in vertex form. That's the new form that we learned for a quadratic function. It's in vertex form. And the transformations, since I know that it has this minus 1 and it has the plus 2. The minus 1 moves my function, to the right one. Excuse me, Miss Wonder. Right 1 unit. And then the plus 2 on the outside of the parentheses moves it up 2 units. My parabola will always be opening upwards if my a value is positive. So if you guys look right here in front of the parentheses, there's no negative. Remember that negative reflects it. So I'm not reflecting, so I'm going to be opening up because I have a positive a value. A is greater than 0. My axis of symmetry and my vertex, I can actually find them just by looking at the equation. So because of that minus 1, I'm going to move to the right 1, and I'm going to move up 2. Well, if I move right 1 and up 2, I'm going to be right here. And that tells me that my vertex is at 1, 2. So that comes directly from the opposite of the number that's on the inside of the parentheses. And then the positive 2 is my y value that's on the outside of the parentheses. That means that my axis of symmetry is going to be x equals 1. Because I'm taking just the x value. Let's go ahead and graph it. I've only moved my shape right and up. I have not stretched it and I have not reflected it. So if I have not done either of those things, when I come over to graph it, I can use the same pattern that I used to graph my original parent function. I can go 1 over, 1 to the right and 1 up. I can go 1 to the left and 1 up. But then because I'm squaring, if I go 2 to the right, I have to go 4 up. And and that is away from the vertex. So I'll go 2 to the left of the vertex and then up 4. Okay? And I use those little dots just so I can remember how far I've traveled, but I really don't need them. And then I just connect and make my U shape. Remember, not a V shape, a U shape. As much as I can make it look like a U. When we talk about solutions, just like you did with linear functions, we're talking about when you cross the x-axis or when f of x is equal to 0. We call these your x-intercepts. Sometimes you call them roots. You call them a 0. So does this function ever cross the x-axis? No. So for this one, I have no solutions because it doesn't cross. My domain, because the arrows go up to the left, so I'm going to say up left and up right. Domain deals with left to right, so I went all the way from the left, negative infinity, to positive infinity. My range does not go down, it starts at 2. So I start at 2 and then I go up. And I'm going to put bracket around 2 and then infinity goes up. I am increasing from the vertex right here. I'm increasing from the vertex and then to the right. So I'm starting to increase at, I'm not at 0 anymore with my vertex. I'm at 1. Remember, we're writing down the x values for increasing. So from 1 to infinity. And I'm decreasing from negative infinity until 1. In this unit, we're going to start to write our end behavior properly with the appropriate notation. So what we are going to say is that as x goes to negative infinity, what happens to y? And this is where you guys would write the left, right, up, down. As x goes to negative infinity, that means when we're looking to the left. My y value is going up. It's going to positive infinity. So this means I'm going up. Now let's go to the right. As x goes to positive infinity, what does f of x do? What does the y value do? So again, this is now when I go to the right. Well, it's also going up. So I'm going to put positive infinity there. And that means I'm going up. Let's do one more example together. How about this one? It is still in vertex form. I now have a 4 on the inside of the parentheses, so that means I'm moving left 4. Plus 2 on the outside means I'm moving up 2. The negative a value means I'm reflecting. And because it has a 2 there, that means I am also stretching. So I know that my a value is negative because it's a negative 2. That means I'm opening down because I have reflected. My vertex, I'm going to go to vertex next because that's a little easier to do. It's opposite of the inside. So since the inside was, gotta erase to make sure I see it correctly. My inside was plus 4. So it's always opposite when it's on the inside of the parentheses. So negative 4 is my x value and then positive 2. And that makes my axis of symmetry x equals negative 4 because those two x values always match. Let's go ahead and graph it. So my vertex is left 4, 1, 2, 3, 4, and then up 2. I am opening downwards, and I'm stretching by 2. So here's the deal. I would normally go 1 over, 1 down. Because I'm stretching, though, when I go 1 to the left or to the right, I now have to multiply that 1 by 2 because I'm going to pull it even further. So I'm actually going to end there. And remember, they're symmetric, so if I have 1 on one side, I'll have 1 on the other side. And then if I try